Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology. Subject code OMD 551, Unit 4, Topic Cardiac Output Measurement. Objective to know about the concept of cardiac output and their measurement. Cardiac output measurement, it is the amount of blood delivered by the heart to the aorta per minute. It also a major determinant of oxygen delivered to the tissues. Here in this, due to this cardiac output may result in low blood pressure, reduced tissue oxygenation, poor renal function and shock. Here also the blood pumper from the heart with each beat for adults is between 70 to 100 ml and the cardiac output is 4 to 6 liters per minute. Then the cardiac output is estimated by using the following methods: direct method, fixed method, indicator dilution method, dye dilution method, thermal dilution method. First we are going to see the direct method. In this method the cardiac output is measuring the stroke volume using an electromagnetic flow probe placed on the aorta and it is multiplying it by the heart rate. Then the method involves in surgery, so not preferred in routine applications. The next method is fixed method. It is measured by continuously infusing oxygen in or out from the blood and measure the amount of oxygen before and after passing. That means the method is complicated, it is difficult to repeat and also we need catheterization. The next method is indicator dilution method. It is one of the most popular methods and it employs several different types of indicators. Here we have two methods are generally employed for introducing the indicator in the blood serum. First one is continuous infusion method, that means but not widely used due to the indicator recircular process. The next one is bolus injection method. It is the amount of blood known by an indicator using dye and it is administered into the circulation. Then the figure shows the presence of indicator in the peripheral artery. It is detected by the transducer and it will be displayed on a chart recorder. Therefore, the cardiac output on the chart is in a curve form. Then the curve form is called as a dilution curve. Here the waveform shown the run of the dilution curve is explanatory. For calculating the cardiac output from the dilution curve, Q equal to M divided by average concentration of indicator per liter of blood for duration of curve into curve duration in seconds. That is equal to M into 60 divided by area under the curve into 1 per minute. Here M represents the quantity of the injected indicator in mg. Q is the cardiac current, C is the concentration of indicator. Therefore, Q equal to M divided by integral 0 to 1 C into dt, so that the evaluation of the dilution curve is simplified and replotting the curve on semi-logarithmic scale paper. Next, we are going to see the dye dilution method. In this method, it is used for the indicator substance in a dye. That means indocyanine green dye is usually employed for recording the dilution curve. So this dye is preferred because of this property of absorbing light in 800 nm. Here it is the densitometer is used for the quantitative measurement of dye concentration. That means in order to avoid the formation of bubbles, a pot type tube should be flushed with a silicon in ether. So only the flow rate of 40 ml per minute is referred in order to get a short response time as possible for the sampling catheter. Then the output of the photocell is connected to a low drift amplifier. That means it has high input impedance and the low output impedance. Then the amplification is directly proportional to the resistance value of the potentiometer R. Then the next method is thermal dilution method. It will produce a resultant temperature that will change in the pulmonary artery and the integral is inversely proportional to the cardiac output. That means cardiac output equal to a constant into blood temperature minus injected temperature divided by area under the dilution curve. That means it is the system calibration is based upon the use of an injection of 10 ml of 5% solution at a room temperature in the range of 18 to 28 degrees Celsius. So, the reduction in temperature of pulmonary artery is integrated with respect to time, and the blood of flow in the pulmonary artery is computed electronically by a computer. It may vary from one patient to another over a range of 30 to 40 degrees Celsius. Here we have the timer or control unit generates the switching signal necessary for proper integration. So the cardiac output is displayed between two ranges, that is 0 to 10 1 per minute and 10 to 20 1 per minute. So only the cardiac output can be determined electronically by the impedance method. Then the measurement of cardiac output, we have three techniques. First one is impedance techniques. That means it can be determined electronically by the impedance method. Then the next one is ultrasound method. It is used to measure the velocity of blood flow in the ascending aorta by the application of Doppler principle. Then the next one is bioreactance method. It is a method for non-invasive hemodynamic monitoring. It is used on bioreactance method. Thank you.